like tell her that there's like a random quiz.
There's a unit circle quiz tomorrow. Okay, finishing up number 14. So we did the first derivative, and then I was like debating what I wanted to do. But let's go ahead and find the second derivative, since that would be technically step 1 under ordinary circumstances. So what situation am I dealing with here?
Is my brain even there?
What's happening to these things here?
They're being multiplied.
Okay.
Oh, Huey.
So I have what?
Product.
And within that product rule, I also have a
Whatever the E rule is.
chain rule.
Oh.
Okay, so
Close enough.
I would have the derivative of the first, so -2, and then times the second, e to the -x squared, plus the first, which is -2x, times the derivative of e to the -x squared, which is technically just the derivative of what we had to begin with in our initial problem. So it's just this piece here, basically. So
Makes sense, because that's
-2x e to the -x squared. So then just to simplify this, we'd have -2 e to the -x squared plus 4x squared e to the -x squared. All right, so we need to set the first derivative equal to 0 to find any critical points, because we said yesterday we don't have any endpoints on this, because let's go back to what the actual instruction said. Use analytic methods to find the extreme values of the function on the interval and where they occur. Identify any critical points that are not stationary points. And we were going to use the second derivative test on this one. So set this equal to 0 and solve. So I divide by -2 and I get x e to the -x squared equals 0.
Okay, so I was turning pages in my book, so you said set it equal to 0. And
Yeah, set the first derivative equal to 0 and solve. Now, can e to the -x squared be 0 at all?
I don't see how that would be possible.
Right, so basically we can just treat that as a number, so it's going to go away, like we're dividing by it, so we just get that x equals 0. So this is a critical point. So then we take this number and we plug it into the original. So k of 0 would basically just give me e to the 0, which is 1.
Not 0.
Then we evaluate the second derivative at 0, and we see what that is and compared to this to determine if it's a min or a max. So k double prime of 0. So if I put in 0, I get -2 plus, well, putting in 0 for x, that's going to be 0. So this is equal to -2. So then I compare this second derivative value to this original value, So negative 2 is less than or equal to 1. Therefore, it's a max.
So if k double prime is at that point is less than or equal to
Whatever the number plugged into the initial is, it's a max. So then we would say there is a max of 1 at x equals 0. All right, 18, because that one was weird because they didn't give us endpoints. F of x. Why is this thing doing this? It's being weird. Equals x to the 3/5, and we're told that negative 2 is less than x, less than or equal to 3. So my interval is half open. So it is from, in parentheses, negative 2 to 3 with a bracket. So what does that tell me about endpoints?
So 3 is an endpoint, but negative 2 is a whole.
Yep. There's just like a gap there. So we're only going to have one endpoint compared to some of them. Obviously, we have two. And like I think the first problem we did, we had that. So first derivative.
I feel like this is going to be an actually stupid question. Is it possible for us to have more than just 2 endpoints?
No. Not in like one function. Like you could have like 2 different intervals, but that's different.
Fascinating.
So. Because like this function obviously takes on more than negative 2 to 3. Well, I say obviously, I think it does. I don't think it'll cause a problem. Anyways, so they could give us different intervals, but we're only looking at one at a time.
I can't think of any x values that would make any problems.
That's what I was thinking. That's why I was like really quick to be like, oh yeah, there's not any issues, and then I was like, wait a minute, if they gave me that interval, let me check. So what would the derivative of x to the 3/5 be?
3/5 x to the negative 2/5.
Yep. And we would set this equal to 0 and solve. So what is x equal to?
I'm gonna say 0.
Yep. So then I look at in the initial equation. So the critical point, I'm just doing this for notation. You don't have to like actually do it this way when you do it. But for the critical point, f of 0 is equal to 0. And then the endpoint would be f of 3, which would be 3 to the 3/5. And I believe that's the way that they leave their answer on this one. Yes.
Would that be the same as the 5th root of 27?
Yes.
Something like that.
Yeah, they just leave it like this. But yes, actually on my paper I have it written as the 5th root of 27, but just because the book does that. So, again,
Wow, so much scrolling.
I know. I'm trying to get back to where I have the second derivative test written.
Never ends. Oh, I guess it did end.
Well, I was looking for...
Oh, it's still going.
Where is... I need to fix something in the last problem. It's not supposed to be compared to the original number. It's supposed to be compared to 0. I need to fix that. We'll go back and fix that in a second. So if the second derivative is greater than 0, it's a min. If the second derivative is less than 0, at that point, then it's a max. So we'll run the second derivative test, but I'm going to go back and fix that other problem.
I mean, we still end up with the same answer.
Right. I was like, in this case, it's not going to make a difference, but if you're going back to look, I want to make sure that we've got it right in here. So this should be 0. And I'm just going to note here that this is the second derivative test. Just so that we have it. I don't want to give y'all false information. Also want to fix it on this paper over here.
That would be kind of sad if we had a whole bunch of those on the AP exam and then we got them all wrong.
Okay. Take care of that notation.
I think that if I were to do bad on the AP exam, that would just be an error on my part.
Was that last year's? No. 2 years ago? They said it was like one of the hardest ones. I think I don't even understand why some years it's harder than others and vice versa. But
Last year, didn't they say that they had prepared for one thing to be on there a whole bunch and there was only one of them?
Yeah, there's one thing that used to be on every single AP exam. It was just known that you were going to have one of those, and they didn't have a single one of them. I was really irritated because we spent quite a few days on it because I was like, oh, it's important. So this year we'll do the section obviously, but I'm not going to spend as much time on it because the prep book that I have didn't even spend that much time on it, and I was like, that's really weird because it's always on the exam, and then it wasn't.
Love that.
So it's fine. It's at the end of this chapter actually.
Oh.
It's 5.6 maybe, I want to say. It's related rates. It's actually a really useful thing to know. That's why I don't know why they don't put it on there, but whatever.
You can actually use it in the real world.
Yeah. My dad wanted me to use it to figure out about a shadow from our tree to see how tall the tree was. So I forgot about it, so I never did it, but I could have done it. He was trying to see how much it would cost to get the tree taken down because they charge by the foot. Anyways.
Just like you did the tree compressor and make it shorter.
Yeah. So the second derivative, so going back to 18, is what?
Hold on, let me get my thoughts straight. I'm gonna say -6 25ths x to the -7/5.
Yes. So if we evaluate, if we do it at the critical point, we're just going to get 0 equals 0, which is nothing. As far as a min or a max, it basically just tells us it's a nothing.
Imagine being a critical point and then being told you're just nothing.
But f double prime of 3, if we do this, this is a weird one, -6/25 times 3 to the -7/5. I think it might be a good time to just get out the calculator and see what this number is. Well, truthfully, does it matter what the number is?
I'm curious though.
Well, yes, but I'm just saying, if this was on the no calculator portion, could you still determine if this is a min or a max?
Mm-hmm.
Why?
Because we're just comparing it to 0, and gonna be negative.
Yep, it's going to be negative whatever. So even if we didn't have a calculator, we could still determine. I don't know why that looks like a weird negative. Go away!
That's not a negative.
It's not a negative now. What is happening?
That's just a funky dot. Oh, it's gone now. Well, you got your negative.
Negative whatever, which is less than 0. So it is a max. Did you figure out what the number actually is?
So how far out do you want me to go?
Like decimal places?
Yeah. The first thing after the decimal is a 0, though.
Is there a number before the decimal?
No. Well, a 0. But
I would say just like 3 places. 'Cause it doesn't really matter that much.
negative 0.05. I'm gonna say 2.
So that's less than 0, so it's a max. So we would say then, because the max occurs at the original value, there is a max of 3 to the 3/5 at x equals 3. Okay. Find the extreme values of the function and where they occur. Okay, so 22. That problem's not even done. Y equals x cubed minus 3x squared plus 3x minus 2. Oh, I know why I chose this problem. Okay, what's first derivative?
I don't know why you chose this problem.
You'll figure it out in a minute.
3x squared
I was like waiting for it. I was like, are you going to say this squared?
minus 6x plus 3.
So then, from there, we can factor out a 3. And set it equal to 0, setting the first derivative equal to 0, which gives us, what's in here?
One of them, trinomial, whatever it's called.
A perfect square trinomial, which gives me what?
X minus 1 squared.
Yep, and since I'm dividing like into 0, I just got rid of the 3 when I did that also.
Makes sense to me.
So x equals
1.
1. So this is a critical point because they didn't give us endpoints this time. So I also need the second derivative. What is the second derivative?
6x minus 6.
So then what I do is I use this critical point in the second derivative. So the second derivative evaluated at 1 would be 6 times 1 minus 6, which is what?
0.
0. What happens when we have that situation?
We panic.
The second derivative test fails, and we do what? Just trying to.
Let me get my notes out.
That's what I'm trying to like go back through so I can like just put it up on the screen and show you, but it's under. I literally just had it. Oh, here it is. It's step 4 under the min, max, and inflection points. Let me put it back up here so Virginia knows what we're looking at.
We check the signs of y prime as x increases through c.
Yep. So we're going to look at
Something about tangents.
basically that point. So our point that we're plugging in is what? 1. So we're going to look at, say, 0 and 2, the first derivative evaluated at 0 and 2, and see what happens, and see if it is changing sign from positive to negative or negative to positive, to determine if it is a min or max. If it doesn't change sign, then there's no min or max. Now you see why I chose this problem.
Mm-hmm. So is c just for critical point?
Huh?
Just for brain are we?
Oh,
doing
C is yes, the critical point, or it can be an endpoint. If like we could have done this in the last one, what the step we're about to do, it just wasn't going to be anything, so I just didn't do it in that one. But so this, so I'm just going to write here, the second derivative test fails. So look for change in sign through C. So we'll look at y prime of not 1. That's not going to help me. Of 0. So if I put 0 in the first derivative, what happens? Is it positive or negative?
I'm gonna say it's positive.
Yep, it's positive. What if I put in 2?
I think that's also positive.
It's also positive. So the sign of y prime did not change. So no min or max. It's always kind of sad when you do all that work and it's just like, there's not one. I can't decide if I want to do that problem. I guess we probably should. Trying to leave that handy for reference. Okay. Then 24. Y equals 1 over x squared minus 1. See if you remember how to find the derivative with the quotient rule.
Okay, I was gonna ask if I was crazy for wanting to do quotient rule.
No, you're not.
Okay. So that's 0
Yes.
minus 2x times 1, I guess, over x squared minus 1 squared.
Yes. I'm going to go ahead and set this equal to 0. So, where does, or what value of x makes this 0?
One. No, that makes it undefined.
Negative 2x equals 0. So, x equals 0. Oh my gosh.
You should have asked what makes it undefined. I would have gotten it right.
Oh, it's been a long break apparently. So this is the critical point.
3 weeks with no math. What could go wrong?
All right, the second derivative would be what?
Hold on. Negative 2 times x squared minus 1 squared. Oh, I got my parentheses all wonky. Minus is that 2 times x squared minus 1?
Chain rule.
Yeah. I was not really chaining the rule as much as I thought I was.
Okay, so maybe we need some derivative review.
Yes, please. So are we having a derivative quiz tomorrow? Instead of a unit circle quiz?
Maybe a bunch of quotient rules and product rules and some chain rules.
Yeah, that would help.
Yeah, I think that might be beneficial.
Yeah.
All the trig derivatives, the the log, all the things.
It might just turn into a log at this point.
Could be a Yule log.
Yeah.
All right, so I'm going to rewrite this just so it's easier to deal with.
Please do.
Negative 2 times x squared minus 1 squared plus, oh gosh, 8x squared times x squared minus 1 over x squared minus 1 to the 4th. Now, I could reduce this farther, however, all I need is to plug in and evaluate the second derivative at 0, so I'm not going to.
Can we get rid of some of the x squared minus 1s?
You just really want to get rid of them?
Yes, please.
Okay.
They're
I'm going to do
freaking out.
something that I'm normally very anti and just cross things out because I don't feel like rewriting the whole thing. So I factored it out and I canceled. That's what I did, everyone. Okay, so now we can evaluate the second derivative at 0. So we get -2 times -1. Gotta watch these signs here. Plus 8 times 0, so that's just gonna go away, over -1 cubed. So that means I've got 2 over -1, which is -2. Oh, thank God. The answer, we have the right answer. This is less than 0, so what does that mean?
It's hold on. Max.
Yep, local max. Now we need to figure out where. So we take
And
the critical point and we plug it into the original. So y of 0 equals 1 over 0 minus 1, which is -1. So that means that I have a local max at the point 0, -1. I don't even know what I assigned them for homework last year. Like, I literally don't even have no recollection. Okay. Any questions?
yes, but I don't know what they are. Not sure if I'll ever know what they are. But
Let's hope Virginia listens to this so she knows there's a quiz tomorrow. I don't even remember what numbers we did. I gotta go back and look. Okay. We're gonna say 1 through 11 odd because 1 through 9 are just, they're the ones where you're just looking at the picture. Hold on. I think y'all should be okay with 15. 15, 17, 20, 21, 23, that's probably fine. Yeah, we'll just go with that.